Hi guys, let's take a look at this question. 8.1. Define acid in terms of the Lowry-Bronsted theory. Lowry-Bronsted says that an acid is a proton donor. 8.2. They give us an acid-base reaction here and they tell us to identify the conjugate acid-base pairs in the above reaction. Okay, so if we take a look at the first one, oxygen, right? Oxygen usually has 2 negatives, but now it only has 1 negative. So it donated a proton. So that is the acid, and then the other one has to be the base. Then ammonia. Everyone knows ammonia, and ammonia is a base. So then the other one has to be an acid, and that will be your conjugate base pairs. That's how you would draw it. Define the term ampholyte. So an ampholyte is a substance which can act as an acid or as a base. Choose an ampholyte in the above reaction. The ampholyte here is H2PO4, or you could have just said HPO4, and you can write the charges if you really want to. 8.3. 10 grams of an impure sample of sodium carbonate is added to 100 centimeters cube of 0.2 moles decimeters cube solution of hydrochloric acid. The acid is in excess, and they give us the equation, and they're asking us to balance that equation. So I think it's very easy. So there we have 2 sodium, we have 1 carbon, 3 oxygens, 1 hydrogen, 1 chlorine. But here we have 2 hydrogens. So we'll have to add a 2 here to get 2 hydrogens. But that means now we have 2 chlorines as well. So I'll have to add a 2 here as well. So now it balances. So I have now 2 sodiums, 2 chlorines, 2 hydrogens. But what about my oxygens? Let's take a look. So I have 1 carbon, that's balanced. I have 2 oxygens and 1 oxygen, and I have 3 oxygens. So that is balanced. Okay, and that is it for the balancing equation. Then they want us to calculate the number of moles of hydrochloric acid. So they've given us the concentration and the volume. They've given us the concentration and the volume, so we can just use this formula. The concentration is 0.2. The number of moles is unknown, and the volume is 100 centimeters cubed, but we want it in decimeters cubed, so it's 0.1. I multiply to get my number of moles, which is 0.02 moles. As easy as that. I'll see you in the next one.